Hi everyone, welcome to this video, part of a series of videos for our Foundations of Research Data Management for GIS course. I'm Dr. Nick Bierman, and in this video, I'm going to give you a quick recap on GIS data and file types and talk a little bit about the importance of file management. So just to start off with, we have two types of GIS data, vector data and raster data, and they're two different ways of representing the world, two different conceptual models, if you like to think of it like that. So first of all, vector data is views the world as a series of discrete objects with gaps in between, and raster data views the world as a continuous grid, so everywhere has a value. So let's go into a bit more detail. Vector data is often split up into points, lines, and polygons. A point is, as it sounds, literally one point, so defined by a pair of coordinates. A line is a series of points connected in a certain order, and a polygon is a series of points connected in a certain order to make an enclosed area. Typically, we would use points for locations, street addresses, points of interest, that sort of thing. Typically, we'd use lines for linear things, so roads, rivers, railways, that sort of thing. And polygons we'd used for enclosed areas, so things like building footprints, lakes, administrative areas of various different sorts, whether it's counties, countries, LSOAs, or even whole countries. Vector data is probably the more common type of GIS data, particularly if you're dealing with people in some form or other. The other type of GIS data type is raster data, and this is a continuous grid. Each grid cell will have a resolution, a certain size, and it can range from very, very coarse data, tens of kilometers, hundreds of kilometers, or even degrees of latitude and longitude, all the way down to very fine details, so 50 centimeters, 10 centimeters, and so on. Each of these cells has a number, and that number represents the data. Sometimes that number directly represents the data, so elevation above sea level, mean average temperature, something like that, population density, numbers of people in that square kilometer. It might also be categorical, so we get land cover data, and then we use integers. So 1 is urban area, 2 is coniferous forest, 3 is deciduous forest, and so on. Satellite data is also classified as raster data, and so this is where the number represents a light reflection, so the color in the visible spectrum or the wavelength in the invisible spectrum. So these are our two main types of GIS data, vector and raster. You can convert between the two. Typically, you would generally use one for a specific project, but it varies depending on what you're doing. The other really important aspect is vector and raster data are stored in different file types. So, for example, a shapefile can only store vector data, whereas a geo package can store vector data or raster data. And there are lots and lots of different file types. ASCII grid is a very common raster file type. GeoJSON is a relatively common vector file type, and there are many, many others as well. So it's important to be aware of both the data type, so is it vector or raster, and the file type. How is it actually stored on the computer? And in any typical GIS project, we will have what we call GIS data files and project files. So data we've already talked about, shapefiles, geopackages, all that jazz, which is great. We also have project files, and these are the kind of supplementary files. So if you click on project and save in QGIS or project, save project in ArcGIS Pro, these are the files it creates. So this is a list of the data layers you're using, plus any kind of symbology, formatting, classification that you've used, plus any map projects that you've worked with. If you're working in R or Python, these would be the R or Python script files, the R project files, and that kind of stuff. So we need to make sure we both sort out our GIS data and these kind of associated project files. So we need to make sure we're clear with where these are. And it's worth saying that file management and data management is really, really important. You know this from working with GIS, but you generate lots and lots of files. So it's really important to have some sort of system. Otherwise, things can get very confusing very quickly. If you're working on your own, you can be a little bit laissez-faire with this and get away with stuff. If you're working with other people on the same project, it's much more important because you need to make sure everybody is clear where stuff is being saved. Otherwise, your colleague will do some work and they'll save it. And if you've no idea where it is, you can spend ages trying to find what they're doing. So this is why it's really important. This is a nice example from a colleague of mine who worked for a big consultancy company. So they organize all their work by projects. So they would have a project folder, and then within this, they'd have a structure a bit like this. These were generally pretty large projects. So, like 4 or 5 people for 6 months to a year, maybe more, depending on what it was. They had this folder, incoming data, where any data, whether it's received from the client or downloaded from the internet or elsewhere, was saved in that folder. Give it a name, who it's from, what it is, where you got it, when you got it. But the really important bit, this should be read only. So the idea is that you never edit this data, you never touch this data, you never do anything to this copy of this data. So it's always there. So if your editing goes wild and corrupts some data or something like that, you've always got this as a backup copy that you can get to. So you don't have to go back to the client and say, I'm really sorry, can you send your data again? Which looks quite unprofessional. They also then had this work in progress folder and shared folder where they would put stuff that they're currently working on. They actually subdivided it further. So they've split it into documents, figures, MXDs, which are project files for ArcMap, and processing. Processing being kind of temporary folder for working files and stuff. Figures for map outputs and documents for reports and that sort of thing. If they wanted to share this internally, they'd use this shared folder and share that with other colleagues in their group, and again, have it as a read-only one. They also had this issued folder. So this is when they sent stuff externally to a client. Who's it going to? What date and what is it? And again, this is also read-only. So this is really, really helpful when your client comes back to you in 6 months' time and says, oh, hi, I love that map you did for us 6 months ago. Please, can you send a copy of it? Rather than having to work out exactly what you did and where it was, you can just find the folder and send, here you go, here's the report again. And they also had some extra bits and pieces in there. So data management folder for licenses and kind of general resources for logos and other bits and bobs. This is probably quite a big setup for some projects, and it may not be viable for a kind of project you're working on your own, but hopefully you can get some ideas from this and apply this to your own work. It's also worth thinking a bit about splitting up our data between project data and geodata. So project data is stuff that's specifically for this project. So for this analysis, this map, whatever it is you're working on. And then geodata is common data that you can use across multiple projects, typically base maps and that sort of thing. And I store geodata in a separate folder, so not within the project folder. And I've got one called geodata, and you can bring it into each project as and when you need it. And this avoids data duplication, particularly if you're dealing with um, a lot of data. A lot of base map data can be quite large, and there's no point having like 4 or 5 different copies on your machine. You can just have one copy and add it in when you need it. Here's the folder structure on mine. So we've got some Corin data, land cover stuff, and we've got some aerial photography. This is from Edina for academic work, Natural Earth, OS Open data, both very useful data sets, and some stuff from World Pop as well. And I often have OpenStreetMap data here as well. Lastly, I just want to mention most of the time we'll store GIS data in files, so shapefile, geopackage, and so on. And this works really well if you're working on your own or in a small group, and this is fine. If you're expanding your work, working with larger groups, particularly if you've got multiple people editing files, working with shared files gets a little bit trickier. And sometimes databases are a better way of storing data and sharing it between multiple users than files. We're not going to say any more about this in this session, but we'll pick this up in session 5. Thanks for listening, everyone, and thanks to NFDI4Earth and the DRA, and looking forward to seeing you in the next video.